120. Okay, so let's start in on the lesson stuff. Here we go. Okay, lines L and M are parallel. Mentally evaluate the measure X in each figure. All right, so here's this, here's that. We recognize that these are parallel, so just obviously this is the same value as this, right? If you took this angle and slid it up here, you translated it, it would fit perfectly up there because parallel lines, right? If you translate a parallel line to another parallel line, it will just make it disappear. So these angles have to be the same. So X here has to be 40. Let's take a look at this. We know about this. What kind of angles are these? Remember, this is a sandwich, and this is different sides of the toothpick. So this is alternate interior angles, and they are the same. So this is 61, and that is 61. Okay, this one, we have two parallel lines once again, and we have this one. These are not alternate interior because if it was alternate interior, it would be this one and this one. But this one is the same as this one, right? This inside one here is the same as this one over here. So that means, if you think about this, this is going to be 98. But if you think about this angle here going all the way across, this has to be 180, right? Because this is a straight line. So that would be whatever this is this 180 minus this part here, which was 98. So 180 minus 98 is, what is that, 82? Who's got a calculator? Somebody's got a calculator. Let's see if we can find a calculator really quickly. All right, 180 minus 98 equals 82. Bingo. Awesome. Okay, so there we go. Okay. All right, so that one and that one add up to 180. Also, you could think about this, right? This X up here is going to be this angle right here. So same thing here, 98 plus X has to equal 180. Okay, here we go. 125. This is an exterior angle, but these are alternate exterior angles, right? This one is going to be the same as this one because it's a vertical angle. So this one's 125. If this one's 125, that means that this one over here is 125 because they're alternate interior angles. And this one have to be the same because they're vertical angles. So 125, 125, 125, and 125. All right. Here are intersecting lines AE, that's this one right here, and CD, that's this one right here. Translate lines AE and CD by the directed line segment from B to C. Okay, so translate AE and CD by directed line segment from B to C. So, all right, so I'm going to translate by vector. I'm going to translate AE, that's this one, from B to C. Hey, look at that. I got a parallel line, right? And so if I do the same thing, I'm just going to do these points individually as well, from B to C. And I'm going to do also point E from B to C. And that'll give me E prime here. All right, cool. So, and then it says also CD from B to C. Okay, CD from B to C. Okay, so CD from B to C. Okay, well, that's not all that shocking because we just translated it right along the track that it's running on, right? So that's not a big deal. So the only thing so B would land where C is, and C would land down here, right? So if I translate C by B to C, I will end up with, oh, it's not letting me, but that point, there it is. Ends up right there, right? Because it shifted down. And of course, B would end up here. B prime would be right here, I mean. Okay. And so, yeah. Okay, and of course, B from B to C It's not letting me. Well, B prime would end up here. Okay, great. What's true about lines AE and A prime E prime? So this line here and this line here, well, shucks, they're parallel, right? Because we did not change the orientation. All we did was move it over. Okay, so it has to be parallel. Okay, congruent angles. For each pair of congruent angles that you find, explain your partner how the angles are congruent. Okay, so let's see here. What are some congruent angles here? Well, ABD has to be congruent to CBE because they're vertical angles. DBE has to be congruent to ABC, right? This angle and this angle have to be congruent because they are vertical angles. We have ABC, and that has to be equal to BCE. So this angle here and this angle here have to be congruent because they are alternate interior angles. Let's see, A prime CB has to be the same as ABD, right? Because all we did was shift this line downward, right? So this angle here, right here, has to be the same as this angle right here. Okay, and we could do this all day, right? There's a ton of them, right? Okay, great. All right, rotate line AE by 180 degrees around point C. Okay, so we're rotating around a point, and we're rotating this line around this point by 180 degrees. Now, why didn't they give us a direction? They should give us a direction. No, they don't need to. Not if it's 180, because it won't matter which direction we go, because we're going halfway around. There you go. All right, so let us also do individual points. So A, and we're going to rotate it around C, and also 180 degrees. And we'll do E around point C, and we'll also do 180 degrees. And we'll do B around C, and we'll make that 180 degrees. And it looks like they want us to do D prime as well. I mean D as well. So let's see here. We're going to rotate this point D around point C, and we'll also go 180 degrees. There we go. Notice it lands right on that line. Okay, cool. What's true about AB and AB prime? Well, AB, excuse me, and A prime B prime, right? AB and A prime B prime, well, duh, they're parallel, right? What else do we notice? Look at A is over here now instead of on that side, right? They flipped spots, okay? But they're parallel. Why are they parallel? Because all we did was we rotated 180 degrees, right? If I have something that's going east and west, and I flip it around, then it's going west and east, but it hasn't really changed it's not getting out of alignment, if you know what I mean. Like it ends up being like trolley tracks, parallel. Okay. Take turns with your partner identifying congruent angles. Once again, right? Any angles that are vertical, right? EBD and CBA, right? So these two angles, this one here and this one here, are parallel. Are vertical angles, so they have to be the same. We could do alternate interior angles, right? We could go this angle here and this angle here, right? So CBE, this angle right here, and CB prime E prime, right? That would be another angle over there. Almost had to sneeze there for a second. Okay. Prove that 180 degree rotation takes lines that do not pass through the center of rotation to parallel lines. You may use the applet below if you need to draw a diagram. Okay, so if I have a line and I have a point. And I want to rotate this around this point, and I rotate it 180 degrees. How can I prove that this is, in fact, a parallel line? Okay, well, first of all, let's label. I want to label the points here. Are they going to let us label the points? Nope. Okay, so we'll try this. See if we can get this point rotated around this point. See if it shows up as another point over here. Yes, it does. Okay, so this point and that point. And then we'll do the same thing here. This point gets rotated around this point at 180 degrees. And it ends up over here. All right, so now let's make some lines. Let's go this way. Okay, so let's check it out. I should be able to measure some of these angles. So let's measure this angle right here. All right. And we'll measure this angle right here because that should be the same because they're alternate interior angles. I'm using the right-hand rule here. So this one, then that one, then that one. And let's move these so that I can read these numbers. There we go. And there we go. Look, what do you know? And so if I move some of these around, you'll see that these numbers, no matter what, are identical. Right? Okay. What's the image of a line that is rotated 180 degrees around a point on the line? Well, if I was going to rotate this line here around this point, what's going to happen? Well, we can do it, right? Rotate this line around this point. And if I do it 180 degrees, where's it going to end up? Boom. Hey, what happened? It ended up exactly covering itself, right? Because this point ended up right here, and this point ended up right there. It just spun around perfectly, okay? All right, cool. Well, that is lesson 120. Please move on to the practice problems.